Hi everyone, how you guys doing? First of all, let me welcome you guys to the Unacademy JEE English. Just as you know, is a brand new channel by Unacademy where everything is being taught to you completely in English. Now, this is the series that I host for class 12 students or any other 2021 aspirants who are looking for a quick revision of all their topics and looking to quickly get some concept revision as well as some practice. Okay, so before we get started with today's lecture, let me introduce myself for those of you who might not know me yet. So, my name is Rohit Dixit. I studied mechanical engineering from IIT Delhi, and for the almost past 8 years, I've been teaching physics for the IIT JEE exams, both mains and advanced. Now, as a student, I myself was All India rank 447, and I was also All India rank 192 in the two stages of the IIT JEE exams that I took. Now, I had also qualified the NTC Stage 2, and I was also in the top 1% in the NACP as a student. All this teaching so far had been offline, and offline, I was fortunate enough to have mentored a lot of students to top ranks in the JEE Mains and Advanced, and also in various Olympiads and other competitive exams like KYPV, etc., KVPY, etc. And now I hope to continue guiding you guys to your dream colleges and dream ranks. So, how can you guys, you students, make sure that you are not losing out in this lockdown and you are also managing to get to your dream colleges and top ranks? So this is what you can do. You can get yourself the Unacademy subscription. This subscription will give you benefits like live classes where you get to interact with your educators. Then you also have live polls and leaderboards. You have test series and analysis sessions, and of course you have live doubt clearing sessions. So all these features will help you propel ahead of your competition in this competition, even in this lockdown period. All right. So how do you get this? Okay, so one more thing. Along with all these benefits, Unacademy is also now providing you the opportunity to study from the best educators from all across the India from the comfort and safety of your home. Okay, so again, that's another huge opportunity for you guys. Now, as I said, in an offline world, this would not have been possible. You have only restrictions of studying from the teachers that are available in your city, in your area. All right. So here you are getting amazing opportunity. So make sure you use this. And this is how you can make utilize this opportunity. So first you'll need to install the Unacademy app. Once you have done that, you need to go to the plus section of the app, select your goal as IIT JEE and click on that get subscription button. Once you do that, you will be redirected to the payment page where you can use this code RD Live and select a plan that you want to take. So now you have two kinds of plans available. One is the plus, another one is the iconic plan. So you can take any of these and whatever suits you. And these are going to be the prices after the 10% off. Okay, if you don't apply this code, then the prices are going to be higher. These are the prices after the discount. Okay. Anyhow, so once you click on proceed to pay, you will also realize that you have options of taking up a lot of no cost EMIs. So whatever plan suits you, whatever payment option suits you, you can take that. Don't forget to use the code RD Live and get yourselves this subscription as soon as possible. So let's talk about the iconic subscription a bit. So what is this iconic subscription? This is something new that Unacademy is offering. So this subscription will take your JEE preparation to the next level. You will be allotted personal coaches, and you'll be attending a lot of IIT JEE workshops. You will get time to time expert guidelines. You will have a study planner. Now, this would be a great help to most of the students I know, because most of the students struggle with planning their studies. And then, of course, you have test analysis sessions. Okay, so all these benefits will definitely boost your JEE preparation. So hello Prius Creator Zone and hello S Pandey. Hi Rajesh. How are you guys doing? Okay, so again, those of you who are following us on the J English channel of YouTube can connect with us on the Telegram app using this link so that you're not missing out on any of the lectures and lessons that are being hosted here. Next, okay, so why don't we get started with today's discussion then? So the last class we talked about analysis methods of pure rotation, and today what we are going to do is we will talk about the analysis of general motion. We also started, in fact, and I told you for any kind of a general motion, the mains has not asked too many questions. Mains has limited its focus to pure rolling only. So today we are going to talk about pure rolling, what pure rolling is, and how to analyze pure rolling motion. Okay, so that's the objective for the day. Yes, Sanskar. Yes, yes, yes. Of course, of course. I remember. I remember. How are you, Sanskar? Okay, good evening to you, Amod. Hello, AP. Good to see you guys. All right, so let's talk about pure rolling and rolling motion then. In our analysis of general motion, we will focus only on the motion of these three objects. So mains will just ask you about motion of these three four kind of objects. Either you'll be asked about rings, or you may be asked about the motion of cylinders, which may be solid and hollow, or spheres, which may again be solid and hollow. Okay. Now, pure rolling in general is defined as a motion of any object in contact with the surface. So whenever any rigid body is moving in contact with another surface such that the relative velocity, the two bodies, 2 points in contact is zero, then the upper body is said to be performing pure rolling. Now, other motion possibilities are of forward slipping, backward slipping, and pure rolling. Okay, so these are the three total possibilities. Okay, so again, please note that pure rolling is not only restricted to hello Aftab, how are you? Pure rolling is not only restricted to these shapes, by the way. Okay, so you should remember that. Pure rolling can be seen in other shapes also. It is not only restricted to these shapes. You can even have a hexagon which is performing pure rolling. So if it is just moving like this, so that there is no slipping. As long as there is no slipping between the body and the contact surface, the motion will be called pure rolling. So in fact, IIT JEE has asked a question like this, I think. So imagine yourself that there was a hexagon kind of a thing, or maybe octagon. Okay, so let's take an octagon. Imagine you had an octagon like this. Now, even if this moves such that this every other surface will touch the ground next. So imagine this will touch the ground first, then this will touch the ground, and so on. So even that kind of motion will be called pure rolling because there is no slipping between the object and the surface at the bottom. Okay, so you need to remember that. However, in this kind of a case, you will see. So let's take up an example here where I am saying that this body. So again, this may be any cylinder or a sphere or a ring. Okay, when its side view will be like this. So imagine if this was a uniform object, the center of mass is moving with some velocity v1, and this is rotating with some omega angular velocity omega 1, and it is kept on a plank, and that plank is moving with respect to the ground with some velocity v. Then let's talk about this point A on the body and this point B, which lies on the plank. Okay, so the definition of pure rolling states if there is no relative motion between points A and B. So the 2 points that are touching each other, they should not have any relative motion. Then that kind of motion is called pure rolling. Okay, so if you see that with respect to the CM, so let's call this CMC. So velocity of CM. What is that? Okay, so we know velocity of C is a V1. Okay, I cap, and I also know what is the velocity of A with respect to C. So you will realize that this motion is it has this kind of an omega. So with respect to C, A will appear to move in this direction. Agreed. And what will be the velocity? It will be omega 1 times R. Okay, so I can now write that velocity of A with respect to C is omega 1 times R I cap with a minus sign, correct? Okay, so once I know both these, so now, okay, I had left space here only. You just write it here. So here I have minus omega 1 R I cap. So velocity of A with respect to ground obviously becomes the addition of both, okay? That is V1 minus omega 1 R I cap. Now velocity of B, you will realize, was V I cap. So the condition for pure rolling is, now there are three possibilities, right? There are three possibilities. What are the three possibilities? So let's talk about the three possibilities. Three possibilities arise. Right. The first one is VA is greater than VB. Let's talk about this. What if the velocity of A is greater than velocity of B? Okay, so let's only talk about the magnitudes. Okay, if that is happening, then with respect to the surface, the body's point is moving forward. Now, such a motion is called forward slipping. Okay, this is for forward slipping. Okay, and what will be the condition for forward slipping? Forward slipping condition would be that V1 minus omega 1 R is greater than. Now, second condition could be VA is less than VB. If B is moving faster than A, then with respect to the surface, the body's point will be moving backwards. So please note, when we talk about slipping, the direction of slipping is judged with the direction in which the point of the body will move. If the body's point moves forward with respect to the surface, then that is called forward slipping. If the body's point moves backward with respect to the surface, then that is called backward slipping. If the body's point does not move with respect to the surface, then we call that pure rolling. Okay. So this is called backward slipping. Okay, so the mathematical condition for this will be V1 minus omega 1 R is less than V, of course. Now, the third possibility is that if both these speeds become equal, okay, so your surface is moving like this and your body is, this point is not slipping with respect to this. So it is only moving like this. Now, this is what you call pure rolling. This is pure rolling. Okay. And the condition becomes V1 minus omega 1 R equals V. Okay. So this is, thank you, Sanskar. So this is if your body is moving, touching a moving surface. Okay, the ground is moving. Suppose the ground below is moving. So that is what you can imagine. If if the ground was not moving, or it was not on a plank but on the ground. So if body moves on the ground, or essentially what I'm trying to say is, or V is 0, the plank below it is not moving, then the conditions for these will change. Okay, then condition for forward slipping is that will be that V1 should be greater than omega 1 R. Okay, so for the bodies, CM's velocity should be greater than omega 1 R, and this is what you study mostly. But that is not the limit of your definition. Okay, actual definitions are like this. So that is why I wanted to tell you. The actual definition are not limited to ground. Okay, the surface below can be moving, and these have to be the instantaneous values, by the way. These have to be the instantaneous values. Instantaneously, they have to be true. Instantaneous velocities have to be like this. Okay, so at all instants, they should be like this. A condition for forward slipping would be this. Condition for backward slipping similarly would have been V1 less than omega 1 R, and condition for pure rolling in this particular case becomes V1 equals omega 1 R. Okay. At all instants. Okay. At all instants. Now, if that is true, then you can also say, since this is true at all instants, so therefore, if I differentiate this, ACM would also be equal to alpha R. This will also be true. So these are the two things that will always be true in case of pure rolling. Okay. Now let's move forward and let's try one question. So in this question, you have been told a solid sphere of mass capital M and radius R is hit by a Q at a height h above the center of the sphere. For what value of h the sphere will roll without slipping? Okay, so try this. Hurry up. This is a solid sphere, remember. So what do you think is going to be the answer? a solid sphere, for what height above the center of the sphere will the sphere roll without slipping? Okay, so that is what you have to say. Okay, try this. So hurry up, hurry up. Let's see if you can figure this out. Okay, so what do you think is going to be the answer for this? Okay, so Tanya is fine. Okay, I think I'm not sure, but I think. Okay, so let's see more of you guys try this. This is a standard problem, a very standard problem. Let's get some practice of some standard problems, and after this, we will discuss some previous year questions also. Okay. Okay, this kind of question has also been asked in mains and advanced both, by the way, previously. All right, so anybody getting any answers? Okay. C. Okay. So let's see. Let's see. All right. So what have we been told? So we have been told that you are hitting this ball with a cue at a height h. Okay, I'm not sure. I don't know. I don't know. The options seem a little weird. I don't know. Why do I have a feeling that none of them may also be correct? Okay, so imagine you applied an impulse here. Okay. Okay, all right. I'll agree. But I don't know. The options seem a little off to me. I don't know. I have a feeling that all of them may be wrong. Okay, so let's imagine this is what is happening. Yes. Maybe because I am feeling a little weird about the options. I don't know. So let's see and figure out. Okay. All right. So let's say when you hit the solid sphere of mass m radius r with a q at a height h, you have imparted it some impulse j. Yes, 2 by 5 may be the correct answer. Exactly. That's what I was also worried about. You are right. You are right, Tanya. Absolutely. That is why I was also saying that the options seem a little off to me. So this actually should have been 2 by 5 actually. You are right. I think there was a typing mistake because 2 by 5 would be the correct answer. Hmm. Absolutely. And that is why I told you beforehand only because the options seem a little off to me. Okay, so let's see how you would have solved this. How you would have solved this. Yes, I know. You guys are right. So you would have solved it. Let's imagine that after this impulse, this guy gets a velocity of v, and then it gets some angular velocity omega. So I know from impulse momentum theorem V should be equal to J over M, right? From impulse momentum theorem. Right. Now the angular impulse would have been J times H. I have told you the angular impulse is nothing but R cross J. So R cross G. So let's talk about the angular impulse about center C. So about center C, what I can say is if I take the angular impulse, what will be the angular impulse? Angular impulse would have been J times H, and that should have been ICM omega. Right? This is angular momentum, angular impulse theorem. Angular impulse, angular momentum theorem. Right. So now all I need to do is that I can find from here omega. Omega is JH over ICM. And I know for pure rolling, what do we know that V should be equal to omega times R. So therefore I can say J over M would be equal to JH over ICM into R, of course. So this is what you should have gotten. This is what you should have gotten. You should have gotten H as ICM over MR. So that is what I remembered also. Yes, yes, yes. So H in fact would be ICM over MR. This is a general result that you can remember for any kind of shape. Okay. So because we have a solid sphere, so for a solid sphere, the ICM is 2 by 5 MR squared. So the answer would be 2 by 5 R. Okay. Now you can even find the answers for any object. Now you realize if you applied an impulse above this, then what will that happen? That'll create more omega, right? Such an impulse would be able to create a higher angular impulse. So it will impart a greater omega to the body, but it will still impart the same V. So then the body would have started the motion with backward slipping. And if you would have provided this below, then the body would have started motion with forward slipping. So please always remember that at H, the body starts with pure rolling. Okay, for H greater than ICM over MR, the motion will start with backward slipping. Okay, this is important. This is important. You can use these results. At H less than ICM over MR, the motion starts as forward slipping. Very, very interesting results. You should remember if you can. Okay. Now let's talk about another interesting problem. So this is a very interesting problem. This was asked in JEE Mains 2015. Okay, and this confused a lot of students. So trust me, as I keep telling you, look, though mains will be mostly easy, mostly standard questions, but mains people like throwing, that so-called odd curveball, which will be a highly tricky question, right? Which you just don't seem to figure out. Okay, so this is a curveball from JEE Mains people. Okay, so let's talk about this question. So this says a roller made by joining together two cones at their vertices O. It is kept on two rails AB and CD, which are placed asymmetrically. Okay, so your CD is straight and AB is tilting like this. Okay, this is interesting. Pay attention. It is given a light push so that it starts rolling with its center O moving parallel to the direction CD as shown. As it moves, the roller will tend to go right, go left, and right alternatively, turn left or turn right. Okay, what is this? What is this? What is going to happen? What do you think is going to happen? So think about it. Think about it. How will this move? Okay, take some time. Think about it. This is a very tricky problem. I remember when this exam happened, a lot of students came up to me. They were so confused with this. So, okay, so I still remember when this mains happened. Okay, so think about it. Think about it, and try and give me an answer. Okay, what do you think? What do you think about this question? Again, it's as I said, this is a very tricky question. I still remember. I still remember when we had this paper. Students were so confused, so confused. They were like, "Sir, ये नहीं समझ में आया, ये क्या हो रहा है?" My Roy says, "Hello, sir. Is resonance material sufficient for physics to get top 1,000 rank in advance?" No, not for 1,000 rank in advance, Baba. Samar, I think that must be you, Samarjit, right? Hmm. So no, no, no. With that, with any just with any material, you cannot get rank of top 1,000. No. Otherwise, all the students enrolled in that institute would be getting top 1,000 rank. So most of them would be solving those, right? But yeah, I think it's good enough if you solve all the problems correctly, and if you have worked. So again, all these coaching institute materials are pretty standard. Okay, if you solve any one of them, doesn't really matter which one you're solving. I think you can manage maybe rank in mains, which would be in 20,000. That is the guarantee. Okay. Beyond that, you can't say that if I've solved the coaching institute's material, I will end up in top 1,000. No. Okay. Because you realize, so all these coaching materials are available to everybody almost. All right. And every single coaching has so many students. Like I'm sure 20, 30 students, 20, 30,000 students, or maybe more would be studying in resonance, no, all over India. हाँ, वो हो सकता है, उतना हो जाएगा, उतना हो जाएगा सिमर. Okay. बस उतना ही हो पाएगा, बट उसके बियॉन्ड इट्स योर प्रैक्टिस. Would turn left. Yes, that is in fact the correct answer. AP. Yes, absolutely. Which is very interesting. Which is very interesting, and which is very not easy to see. Okay, it's not very easy to see what is happening here. Okay. Now, even if you had to guess, most people would have guessed it'll turn right because of the way the rails are made. Yes, yes, yes. I can completely imagine. So, what is happening? Imagine what is happening. What is happening? So, imagine after. Okay, so make a side view first of all. Make a side view. Okay, so let's think about this. This is how your two cones are on their vertices. Okay. Now you realize one line is going like this, which is CD, which is fine. So one line is going like this, and another line is going like this. Okay, so what will happen now? What will happen? You realize that if you talk about, so whenever you are at a distance which is greater, the height of the CM would be higher. Agreed. The CMs of both these guys would be lying on this line, the line joining both their bases and passing through the apex. So what you realize is that this distance would be greater, this distance would be smaller. Okay, so if this is x1, this is x2, can I say, because the rails are turning like this, after a while x1 would be less than x2. So can you say this is, if this is h1, so this height is h2, and if this height is h1, then can I also say h1 would be less than h2? Okay. So these I can already say. Now I already know this is performing rolling. So if this is performing rolling, the body has 1 omega. So you realize the point here would be moving forward with some velocity, and let's call that v2, and the point here is trying to move with some velocity, let's call that v1. So what you will realize is that v1 would be h1 omega and v2 would be h2 omega. Now because h1 was less than h2, so I can say v1 is less than v2. Now, since this end moves slower, this end moves faster. So where will it turn? It will turn like this. Okay. This end, imagine, is moving slower and this end is moving faster. So where do you think this will end up turning? It turns towards left. Okay, so that is the explanation. Hello, Meet, how are you? So yes, C is in fact the correct answer. Okay. Very counterintuitive, very difficult to visualize actually. Okay, if you wanted to just think about it, you won't have been able to guess. Okay, if you wanted to guess, of course, you would have probably gotten it wrong. You would have probably thought that it should move right. Even after knowing the answer, a lot of students couldn't understand how it is happening. Okay, even after knowing the answer, this is that a tricky kind of a situation. Okay, so it was interesting. It was interesting and fun to see that mains can ask you an odd, tricky question. So be careful. Okay. Now, how do you analyze pure rolling? Again, for analysis of pure rolling, also you have the same tools available. You can apply F equals MA equations, MACM for the ACM, and then you can apply tau equals I alpha equations with respect to the CM. Alternately, in this particular case, you also have analysis about the bottommost point. We'll discuss about that. That the bottommost point and the axis passing through it are called instantaneous axis of rotation and instantaneous center of rotation, right? To the axis passing through ICR, which is in fact the instantaneous center of rotation, about which the body can be assumed to be performing pure rotation, is known as the instantaneous axis of rotation. You should realize in pure rolling, you should know that since so in pure rolling for on ground, please note for pure rolling on ground only, this will act as instantaneous center of rotation. Okay, because only in that case this is at rest with the ground frame, so the entire body appears to be performing pure rotation about this, so this becomes the ICR, instantaneous center of rotation, and the axis passing through this, is called IAR, instantaneous axis of rotation. So any pure rolling can be seen as an instantaneous pure rotation about the ICR and along about the IAR. So AP says, sir, your Pathfinder lectures are awesome. I always wait for Saturdays just for it. Okay, thank you, AP. All right, so let's also talk about the point at which the instantaneous axis of rotation. Okay, so we already talked about the instantaneous center of rotation. Okay, now instantaneous velocity of ICR is always zero. You know this. That is why it is being called ICR. Okay, by multiplying zero with a vector A is okay. So first of all, you can't multiply zero. You can multiply a vector with a okay zero. Okay, okay. I guess you can null vector, null vector. You will get a null vector. So doesn't matter what you are multiplying it with. Whether you are multiplying it with a scalar zero or a vector zero, you will always get a null vector. Okay, Meet. Now, with the help of the concept of IAR, I can also write the total kinetic energy of the body, and it can be written as a single term. So earlier we used to write the kinetic energy in two terms, half m VCM square plus half ICM omega square. Now you can write it in a single term as half I about IAR times omega square. Why, sir? Answer is null plus. Please let me understand. So what is there to understand? So I said no null. Null vector I told you. So what is null vector? What is null vector? Meet, what is null vector? Okay. What is null vector? First of all, what is the definition of a null vector? A null vector is a vector having zero magnitude. Okay, that is what you call a null vector. So I wanted some space to write that down. Uh, maybe I'll just add a page here. Okay, Meet. So let me tell you about this. See the definition of null vector. This is the definition of null vector. No, what is null vector? Null vector is a vector with zero magnitude. Right. Now, why do I need this vector? Why do I need this vector? The reason why we need this vector is that whenever you're adding, suppose, two vectors or subtracting two vectors, the answer has to be a vector quantity, right? Or whenever you're multiplying a scalar with vector, result would be a vector, right? Similarly, a plus b or a minus b, your result has to be a vector. Okay, so whenever you're performing a multiplication of a vector with a scalar, the product has to be a vector. Whenever you're subtracting two vectors, the subtraction has to be a vector. So what if you did this, a minus a? So since this has to be a vector, this is represented as a null vector. Okay. When you say the summation f external, summation f net force acting on a body is zero, you always say it like this. You don't apply the the vector sign, or you add the vector sign to zero also. Okay, you cannot. This is the correct way of saying this. That the net force acting on a body is zero. Okay, you cannot, if you write this as summation f x equals zero. So this is wrong. This is wrong. So just for convention, because because when you multiply any vector with zero, the result has to be vector. So you write it as null vector. Okay, got it, Meet? So that's a null vector. Because you're multiplying a scalar with a vector. When you multiply a scalar with the vector, the result has to be vector. Okay, this is scalar into vector. Scalar into vector should result in a vector. That is why we are using that notation. Okay, I hope you got it now. Okay. All right, now let's move on and talk about the instantaneous axis of rotation some more bit. How do you identify instantaneous axis of rotation? So I've already talked. If the velocity of any point P and the angular velocity is known, then the instantaneous center of rotation lies on the line perpendicular to v vector at a distance of r equals v by omega. All right, no problem. So here I have been shown to you as the example. So imagine if you knew the velocity of the point P and you also knew the omega, then to find the ICR, you would have drawn a perpendicular first. So first what you would have done is drawn a perpendicular to the v vector like this, and then selected a point which would have zero velocity. Why? Instantaneous center of rotation should always have zero velocity. Okay, so this point is going like this. In the reference frame of this point, what do you see? In the reference frame of any point of the rigid body, you will see the rigid body rotating, right? So in the reference frame of P, all the points above this will appear to be moving like this, correct? Of course, with different velocities. And on all the points in this direction will appear moving like this, right? And to find the ground frame velocity, you have to add to P, the velocity of P itself, correct? So the ground frame velocities would be this plus p vector, velocity of p, right? So that is why if you wanted to find a point which will have zero velocity, it would lie below point P and it would be at a distance r equals v over omega. So that what is happening here is that this velocity, which is the velocity of the point with respect to P, becomes omega times r in that direction, and this is the velocity of point P itself. This is v. So the net sum of this becomes zero, and this point will behave like the ICR. Okay, note this, that ICR is always at rest instantaneously. We have talked about this, right? The instantaneous velocity of ICR is zero. This is very, very important. This is how you are trying to identify the ICRs, that the instantaneous velocity of the ICR must be zero. Sir, I know what is constrained motion, but what is constrained? What? Constrained string and constrained pulley. Okay, I have no idea. So either you are mistaken, you are not writing it correctly. Maybe you want string constraint and pulley constraint. There is nothing like a constraint string. Okay, maybe there can be pulley. Okay, I don't know. So first of all, just be a little clear about what you are trying to ask me. Okay, whether you are trying to ask a string constraint, okay, or if you're talking about actually talking about something called a constraint string, then you may have to give me an example, okay, so that I can understand. So I think there is something missing in what you're trying to say, so that is why I'm not able to understand it fully. So try and rephrase your question once. Okay. All right. Moving forward. So this is one way of finding the ICR. Okay. If you know the velocity of any point, draw a perpendicular to the v vector, find a point r distance above or below, such that that point should be at a rest. Okay. Okay. So for those, you can watch my lectures on constraint motion. I have taken lectures on constraint motion. There I have discussed these in details. Okay, so you can watch these lectures on constraint motion. Constraint means restricted. Okay, so string constraint means whenever motions of any bodies are restricted because they are attached to strings, and pulley constraints mean that the restriction which the motions of any object will have because that is attached to a pulley. Okay, that's about it. The mathematical equation describing that is called the constraint equation. Okay, and if you want to know about that in detail, then you can watch my lecture on constraint motion. Okay, now moving forward with our discussion, as I was saying, if velocities of 2 points are known and these are non-parallel, okay, then also you can find the ICR. So here is an example. So if velocities of point P and Q were known, you draw the perpendiculars on both. Now in the first example, you realize that the ICR lies on the line perpendicular to the V vector, right? So you would have thought that the ICR would lie on this line because P's velocity is like this, and the ICR should also lie on this point because with respect to Q also it should lie on a point which is on a line which is perpendicular to the V vector, right? So of course the point of intersection of these will represent the ICR. So that's the trick. Okay, so there are other methods also of calculating the ICR, but I would like you guys to stick to these two only. These two are the easiest. Okay, these two are the easiest, and you should just stick to these. Okay, so this is how we identify ICR. Now, once we identify ICR, now we can perform a whole lot of analysis about the ICR also. And how do we do that? So since in pure rolling, the rigid body appears to be performing pure rotation about the ICR, all analysis can be done about it. Okay. You can use the tau equals I alpha equations. Okay, so tau about IAR, which is the instantaneous axis of rotation, equals I about IAR times alpha to find alpha. Okay. So please note this. Also, once alpha is known, ACM would be known. ACM would be nothing but alpha cross the R of CM with respect to ICR. Okay, so that is Okay, okay, you do that. Note, if the CM lies at the geometrical center, then there is no pseudo torque about ICR. However, if CM is off this position, then a pseudo torque will need to be considered. Okay, do you remember that? This is a very very important thing. We You do not blindly apply tau equals I alpha equations about the IAR or about without considering the pseudo torques. In case the body is not uniform and it's CM does not coincide with the geometrical center, then you may need to take another pseudo torque. Okay. Again, not in mains probably, but in advanced level questions, you may have this kind of a problem. Okay. But don't worry about it in mains. Okay. Mains will never ask you such a thing. Okay. So, important for advanced. So, right now, if you're focusing on mains, maybe you can forget about this. Mains will never ask you anything like this. This is a very, very tricky situation. Okay. So, trust me, a lot of people have a lot of good students I have seen getting confused in such situations, okay, where the geometrical center does not where the CM does not coincide with the geometrical center. Even teachers I've seen getting confused with this. So mains will definitely not ask you about that, okay. However, you should still know it. Okay, so that's how you perform analysis about ICR. Now, why don't we try some more questions? Okay, so let's try some more questions. This question was asked in JEE Mains 2013. Okay, so JEE Mains 2013. Let's see what this question has to say. It says a hoop of radius r and mass m is rotating with an angular speed of omega is placed on a rough horizontal surface. The initial velocity, the center of hoop is zero. So usually you're just spinning a hoop and you placed it on a rough horizontal surface. So it will skid for a while and then it will start to perform pure rolling, right? What will be the velocity of the center of the hoop when it ceases to sleep? Ceases to slip. That is what you have to find. Okay. Try this. Try this. What do you think it's going to be? Think about this. Think about this. Hello, Karthikeyan. How are you? So try this. Try this. Let's see if you can figure this out. Okay. All right. You're most welcome here. What class are you in? What class are you in, Karthikeyan? It is not there in the playlist. Can you say about Unacademy, sir? So what do you want to know? Tell me. So this is JEE English, which is a new channel for by Unacademy. Here everything related to JEE is being taught you in English. Okay. So this channel was started for all the students who are not very comfortable with Hindi because most of this YouTube content is available in Hindi only, right? So we have a team of highly experienced educators, okay, to guide you through your IIT JEE journey. You can go through that. Okay, so okay. As far as meat is concerned, I'm sure it should be in the playlist. Otherwise, you can generally browse through the videos, and maybe the name of the video would be different. Okay, that's about it. Nothing else. Nothing else. Okay, so go through. Okay, so let's talk about the playlist. Let me also search it in the playlist. Till then, you guys keep trying this. Okay. So you should be looking at the NLM 2022 series, right? Newton's laws 2022 series. What is that? Hmm. Okay, is that not there? So go to the playlist. Go to my thing. Yeah, Newton's laws 2020. Then where do you have Newton's laws 2022? Okay, that is slightly weird. Have they made only one playlist? Hmm. Okay, yes, yes, yes. I can't. But I'm a medium student. Okay, that's not an issue. That's not an issue. Karthikeyan. Okay, so see, there is nothing like a medium student. Okay, there is nothing like a medium student. I have seen such kids who were supposedly medium students till class 10th really take up the challenge, put in some hard work, and become some of the topmost students in class 11th and 12th. Okay, if you saw my results till class 10th, okay, I was one of the better students, but I was not too good because I had never used to study that hard. In my 11th, 12th, I really studied very hard, so I achieved a lot of results. So you can turn that around anytime. All right, so a lot of answers are coming in. A lot of answers are coming in. Okay, so AAC. And okay. So I think C is the correct answer. I'm not sure, but let's see. So how do you solve this? A hoop of radius r of mass m is rotating with an angular speed of this. Yes, me. I can see that. I think it's the problem is that the playlists are not properly updated. So what you can do is you can go to the videos in the channel instead of looking it up in a playlist, and then go a little back, and you will find that okay, the lecture video is still there. It may not have been updated in the playlist. That might be an issue. Okay, okay, meet. So instead of looking for the video in the playlist, you look for that in the video section of the channel. Okay, उसमें देख लो उसमें मिल जाएगा पक्का. Okay. So you have been told that a hoop was originally rotating with a velocity omega naught, and after some time it starts to pure roll, right? You have to find the velocity of the center of the hoop when it starts to pure roll, right? So let's imagine after some time what happens is after some time, let's imagine the center is actually moving with a velocity v, is moving with a velocity v, and this is rotating with some omega. So these are the initial and the final conditions. Now I have told you the trick to solve this. If you remember, you take a point on the ground P, and you can say about P there is never any torque, external torque acting on the object. So the angular momentum of the object about P will always remain conserved. Okay, I hope you remember this trick. So since there will be no external torque acting on the body about P. Why is that? The only force, see, mg and n will always balance each other out because mg and n are always equal. The only force left is the force of friction. The force of friction would be like this. You would have had these forces, okay? You would have had mg, you would have had normal reaction, and then you would have had friction. So n and mg are always equal, and f passes through p. NLM lecture already watched full, sir. Uh, okay. So do you want me to share the link here? So hello, Karthikeyan. Hi to you again. Yes, hello to you again, Karthikeyan. Tell me. So do you want me to share the link here, by the way? Okay. So all I can tell you is that you can use the angular momentum conservation. Okay. So let me just share the link of that constraint motion video with our friend Meet here. That he is not getting more worried. Okay. So maybe me, I don't know what videos you watched. There you should have found the constraint motion video also. Don't worry, if you couldn't find it, I will quickly find it for you and share the link. Okay. Okay. I think here it is. In fact, so here is the link. Okay, meet. Here is the link to that video. Okay, you can watch that. You can watch that, and don't worry, it is there. It is there, Baba. Okay, it is there. All right. As I was saying, to solve this, now we can apply angular momentum conservation about P. So let's try that. Applying angular momentum conservation about P. Let's see what that will get. So I hope you remember how to write angular momentums. Right? How do you write angular momentum? Angular momentum about P. Please remember this. Angular momentum about P is written as angular momentum of Cm with respect to P plus ICM omega. Correct. So initially you will realize that this term was zero. Okay, only this term would be there, so that would be mr square omega. Okay, and the direction would be minus k cap. Okay, and then it would be final LP final would have been mvr plus mr square omega and all with minus k cap. So all you need to do is equate these two. Okay, equate these two. So what you will get is that and use also you will realize V equals omega r, right? Because now pure rolling has started. Now pure rolling has started, so V will be equal to omega r. Okay, so that is what you have to do. So this will become 2 mvr instead of omega r replaced with one V here. We'll have 2 mvr equals. So you have 2 mvr being equal to mr square omega naught. So mr get cancelled, and you realize V equals omega naught r by 2. That's it. Okay. So yes, this was the correct answer. Omega naught r by 2 is the correct answer. So whoever said C is absolutely correct. Okay. So Tanya said C, I think. Yes, Tanya and AP, you were correct. Well done, people. All right, let's move on. So please remember again, this is the kind of question that even mains has asked. Okay, though these kind of questions are the end questions of HCV, but even mains people don't shy away from asking such questions. So remember this trick: apply angular momentum conservation about a point of the ground. Okay, and this will get you the answer very quick. All right. Next, we talk about pure rolling on an incline. I have just recently covered this topic in the regular series for class 11. So all you need to do is uh, take talks about the ICR. So taking thoughts about ICR, what you will realize is for ICR, what you will figure out is that mg sine theta times r would be equal to ICM plus mr square alpha. So from this equation, you can immediately find the alpha. Okay. So alpha was mg sine theta r over I c plus m square. Then you can also find ACM. ACM would be alpha times r. So that will become g sine theta over ICM over mr square plus 1. Okay, commonly used result, important result. You can remember this. Okay, once I know both these, now I can find other things also. Okay, so if I knew the velocity, then what will be the energy? Energy would have been half I about IAR omega square. Directly I can write. And I can solve all such things. What will be the friction? Okay, so let's write about friction also. Mg sine theta minus friction should have been MACM. So from here you can find friction also. Friction would be m times g sine theta minus ACM. Now, if you're asked to find the minimum coefficient of friction to ensure pure rolling, then also you can say that this should be less than equal to mu mg cos theta. So from here you can find the minimum mu also. Okay, mu minimum can be found as the would have gotten cancelled, and 1 by g cos theta g sin theta is AC. Okay, so everything about this motion can be found. Okay, you could have found the acceleration, the angular acceleration. Now the energy, the force of friction acting, and the minimum mu required to ensure slipping. Okay, so all you need to do is just take the thoughts about the ICR, which is the bottommost point, then do whatever analysis you feel like. All right, so now let's again take a look at all the methods available to us for analysis of this pure rolling. Okay, so first go through this. Let's go through this and make sure that this is making sense to you. Okay, we are not coming back to this here. So just go through that. Okay. So constraint, it's not constraint string, it is string constraint. Okay, it is string constraint and pulley constraint. Yes, constraint means a restriction in motion. Okay, you watch that lecture and then you will be fine. Don't worry. You watch that lecture and then you will be fine. So as I was saying, so all the methods of analysis that are available to us. So let's go over them quickly one by one. So we have Newton's laws approaches, then you have work energy approaches, okay, and then of course you have momentum and angular momentum conservation approaches. Then you have impulse and angular momentum, and finally you have all the analysis approaches available with respect to the ICR. Okay, so that also you can do. Okay, so again, try this. So once you know all these methods, all you need to do now is that try starting that again. Okay, so why don't we go with this? So just let me get this. Yeah, we are back to this. Okay, it seems to be working now. Okay, so this is a practice question that I have for you. A solid cylinder is rolling down a rough inclined plane of inclination theta. Then friction is dissipative. friction force is necessarily changing. The friction force will aid rotation but hinder translation. Or the friction force is reduced if theta is reduced. Of the following do you think is correct? Think about this. Think about this. So which of the following options will be correct? Okay. So quickly tell me. Hurry up. Is friction force dissipative? Is the friction force necessarily changing? If the friction force will the friction force aid rotation but hinder translation? What do you think will happen? Or the friction force will be reduced if theta is reduced? Okay. Hmm. That is correct. In fact, that is correct. How about option D? Can option D also be correct? So first of all, you should know that since there is pure rolling happening, so friction is not dissipative. In fact, that is the importance of pure rolling motion. In pure rolling motion, the friction force cannot dissipate any energy. That is why we use this. Now, friction force is not necessarily changing. So we talk about the motion here only. The motion here only. For rolling down, we have just analyzed the motion. So what was the motion? We realized that ACM was your mg sine theta times r square over ICM plus mr square. Correct. So for a solid cylinder, let's just substitute these values. For a solid cylinder, when you substitute these values, what will you get? You will get mr square g sine theta here, and in the denominator, solid cylinder has ICM as half mr square. So half, so that will be 3 by 2 mr square. So you would have gotten this. So you would have had the expression as 2 by 3 g sine theta, right? So you should have known this. And then we realized that the amount of friction acting would be mg sine theta minus ACM, right? So I know the friction acting would have been mg sine theta minus MACM. So if I substitute the value of MACM from here, let's see what I am getting. I am getting 1 by 3 mg sine theta. So friction is in fact reduced if theta is reduced. Okay, so option D is also correct. Okay, so two options are correct here, Tanya. Of course, what is the direction of friction? What is the direction of friction? So if you take thoughts about this, so the direction of friction will be like this. You will notice that the direction of friction would be like this. So obviously this kind of friction would hinder translation and would aid rotation. So you are right. C is absolutely correct. But along with that, even D is correct. Okay, so C and D both are correct. Okay, I hope you followed that. Next, let's try another problem. This is a previous year JEE Mains question. Okay, so this was asked in 2007. We just calculated. I think we just calculated the answer for this. Okay, this you should be able to immediately tell me. So a round uniform body of a radius r and mass m with moment of inertia I. Again, let that be the moment of inertia about the cm rolls down without slipping on the incline, its acceleration would be. So if you paid attention, you should have this. Okay, you should be able to answer this one quickly. So we just derived the formula of this. In fact, in my regular lectures also, I have discussed the formula of this many times. I even showed a GIF of all these shapes, different shapes traveling down an incline. Okay, so if you watch my lectures, you should remember this one at least. So as I keep telling you, this is a very standard result, very often used. So you should remember such kind of results. Okay. Such a direct question has been asked in JEE Mains. Okay, imagine. So what will be the answer for this? Come on, people. Let's try and give me some answer. Okay. Hurry up. Just remember the discussion that we just had. Okay. Just try and remember that discussion only. If nothing else. I just calculated this. Okay, so what will be the answer for this? Hurry up, hurry up. Let us get the answer soon. Okay, so was nobody paying attention or what? Guys, you have to be more attentive if you really want this review session to work for you. Hmm. जल्दी बता दो यार. Not waste much time. Which of these following options will represent the acceleration? जल्दी से बता दो. अरे आप. So a direct question like this has been asked. Okay, those of you who are paying attention can should be answering this quickly. In fact, okay. So Tanya says B. Yes, of course it is B. If you paid attention, we just derived this expression. Okay, I just wrote it here. See here. You take mr square common from here. You have g sine theta over ICM over mr square plus 1. In fact, I have written this here also, I think. You will remember. Here I just derived this. And I told you this is an important result. Hello, Amod Kumar. No, it's not A, it's B. B is the correct answer. Here, when I was showing you the derivation, I derived this also, and I told you, I think I forgot to write. This is important result. JEE Mains has asked direct questions for this. Okay, so here, obviously, this was the formula that you have just derived, and this is the correct answer. Okay. Now let's move forward. Let's talk about some other questions. So here is another practice problem. This is a very interesting problem. A problem like this was asked in the AIMS exam, if I remember correctly. This was not asked from JEE Mains. This is asked in AIMS, I think. So again, a very likely problem to be asked in Mains. Okay, so we are discussing all the previous year questions and a lot of questions which may be asked of you. Let's try this. So you've been told two identical small spheres A and B. So both are identical small spheres. Pay attention to the language. Identical small spheres A and B of uniform density climb up two identical curved surfaces. Initially, both are rolling with the same V. A climbs a perfectly smooth surface. B climbs up a perfectly rough surface. If the maximum heights attained by them are HA and HB, what is the ratio of HA is to HB? So that is what you have to say. Which one do you think will go up to a higher height? Which one do you think will go up to a higher height? Okay. Think about this. About this. This is interesting. Will be the answer. What will be the ratio of the heights attained by A and B? Think about this. So this is a good practice problem. This is not a previous year mains question, but I think this question was asked in mains in AIMS paper sometime. I remember this was an AIMS paper question. The AIMS also asks you good questions. So any NEET aspirants there watching this should be happy. We are covering those kind of questions also, and it is again a very likely question to be asked in mains. If AIMS has asked such questions, so mains can also. Hello ARJ, how are you? What do you think the answer for this is going to be? Yes, good to see you back, ARJ. Okay. So two identical small spheres A and B of uniform density climb up two identical curves. Initially, both are rolling with velocity VA. A climbs a perfectly smooth surface, B up a highly rough surface. If the maximum heights reached by them are HA and HB, then what is the ratio of HA is to HB? 5 is to 5. But there is no option 5 is to 5, Baba. 7 is to 5. Okay. So Amod says 7 is to 5. AP, C is 5 is to 7. C is 5 is to 7. Which in fact may be correct. Let's see what you will happen. What will happen? So imagine what is happening is that you have a surface like this, and you have another surface like this, identical. Okay. Now you have A here, and you have B here. Both are rolling with V. Now this is smooth, right? A climbs up a perfectly smooth surface. This is smooth, and here mu is non-zero, and in fact we've been told it is very high. Okay, so please remember what will happen. What will happen when both the spheres are climbing up? You realize if you take torques about the CM, A does not receive any torques about the CM because the surface is frictionless. So even at the top, when A reaches here, it will still be rotating with its own initial omega. So let's say this is V naught and this is omega naught. You would have seen when it reaches the top, it would still be rotating with omega naught because there is no torque above the CM to retard that omega. So it will keep on rotating. That rotation never stops. While in B, the friction I hope you remember, will act upwards. Will act upwards. While here, friction keeps on acting upwards. So that will provide a torque that would have retarded, in fact, a B, the omega of B. So here you would have seen this would have been perfectly at rest. So that would have been the difference between these two. So V would have been 0 and omega would have been omega naught. Here V equals 0 equals omega. Both V and omega would have fallen to 0. Okay, so that is the difference that will happen when A climbs up a perfectly smooth surface and B climbs up a perfectly rough surface. Okay, this is the difference. Okay, so I hope you understand. In case of no friction, case of no friction, the omega of the object does not change. Okay. Why? As there is no torque about the CM. You saw the torques about the CM, there are none. So there is nothing to retard that omega. भाई ओमेगा कम क्यों होगा फिर कोई एक्सटर्नल टॉर्क होना चाहिए ना एक्सटर्नल टॉर्क ही नहीं है सो अल्फा ही नहीं आएगा अल्फा नहीं आएगा तो ओमेगा कम नहीं होगा so even when it reaches the top it is still rotating with the same omega that omega never changes okay for instance I can give you an example of that a good example of that would be if something is rotated and like this. If something is rotated and thrown upward, so you realize when it is in air, there is nothing to retard its omega. So even when at the top, at the top its velocity becomes zero, but it still is rotating. It still has the omega. So that is what is happening, right? That is what is happening. At the top, it will have some omega, but its v would have become zero. Okay. So I hope you can now remember this. So therefore, in case of A, only translatory K goes to P and for B, both K's translatory plus rotatory. Okay, go to P. And so first of all, B will climb up to a higher height. Okay, and how much will that be? How much will that be? So I can say for A, I can say applying energy conservation half m v naught square should be equal to m h k and for b I will write half v naught square plus half ICM is 2 by 5 mr square the naught square equals mghb. Correct. Now you also know for pure rolling omega naught r will be equal to v, so in fact you would have had half that here you would have had half into 7 by 5 into mv naught square. All you need to do is divide these two. So let's call this equation 1, let's call this equation 2, divide 1 by 2, and that is it. If you divide 1 by 2, equation 1 by equation 2, you would have gotten HA is to HB equals 5 is to 7. I hope you can see that. So 5 is to 7 is the correct answer. C is the right answer. Again, a tricky problem which was asked by Ames, interestingly. Don't think only IITs can ask tough questions. No, not necessary that only advanced will ask you tough questions. Sometimes Ames people have a lot of good physics questions. In fact, that is what I've seen in my teaching career. Okay, so you'll find a lot of good questions there also. All right, here is another very interesting problem which was asked in JEE Mains 2019. Okay, so let's see what does that tell you. That is asking you the following bodies are made to roll up without slipping the same inclined plane from the horizontal plane. A ring of radius r, a solid cylinder of radius r by 2, a solid sphere of radius r by 4. If in each case the speed of the center of mass at the bottom of the incline is same, then the ratio of the maximum heights they climb is again a very similar problem. So I have told you that JEE Mains people ask like asking one sort of standard kind of problem. So you will realize that if you see this question was not very different. Okay. So this is for rolling on an incline. This is also rolling on an incline. So they like asking these standard questions. So get it. Just try and sort this. Okay. What will be the ratio of these heights? Okay. At the bottom, they all have the same velocities. Okay, so try and figure this out. Let's see. Okay, can you take a guess? Can you take a wild guess? Which one will climb to the maximum height? Which one do you think should climb to the maximum height? Think about it. Okay, it should be easy to see, in fact. Very easy to see. So, if whoever has more kinetic energy, would be able to go to the higher point, right? The maximum height. Now, you realize what is the kinetic energy? The kinetic energy of this, of pure rolling, can be written as half ICM plus mr square times omega naught square. Right? You can write the kinetic energy like this. Okay. Now think about this. Think about this. So the bodies are made to roll. Okay. So this is how you would have found the kinetic energy, and what I can find is that this would have been equal to mgh. Okay. So let's just take a quick thing. Okay, from applying energy conservation, I know in pure rolling, what happens is in pure rolling, the friction does no work, so I can always apply energy conservation. Okay, so think about this. So can I say applying energy conservation? What we can say is that half ICM. So in general, I'm writing for any kind of body. This omega naught square or omega square simply would be equal to mgh. Correct. So I can write that. So from here I can find the h, and since both all the bodies had the same speed of center of mass, so that VC equals omega times R. All I need to do is multiply this with R square and divide these by R square. Right. So this is nothing but V. Can I say I am getting mgh equals 1 by 2 m plus ICM over R square times V square. You realize V is the same for all, and M eventually would have gotten cancelled. M would get cancelled for different objects when you start performing substituting these values. So all you need to do is substitute these values, find the heights, and then you will have the answer. One hint that I was trying to say is what was that anything which has a greater ICM, anything that has a greater ICM would have a greater energy, right? So out of these three, who has the greater ICM? The greatest ICM is possessed by this. Then second number is by this. The third number is by this. Okay, the radius also goes decreasing though. Okay. So if I had to make a guess, I would have taken A. Okay. But let's just calculate it. Once I have this, which for a ring would have been equal to square over 2G plus MR square by ICM over MR square. So 1 plus 1 V square over G. H for cylinder. H for cylinder. You realize the R's don't matter. R's really don't matter. No, not really. Okay. For a cylinder, H for a cylinder, you would have seen would be V square over 2G times you would have had a 1 plus again 1 by 2. That'll be 3 by 4 V square over G. And similarly for solid sphere, you would have had V square over 2G. Then you would have had 1 plus 2 by 5. That would have been 7 by 10 square over G. So the ratio would have been H1 is to, let's just quickly write. H1 is to H2 is to H3 would have been equal to, so let's take out the V square over G's. 1 is to 3 by 4 is to 10. Okay, so let's multiply everything by 40. Conservation of mass. No, no conservation of mass involved here. You are getting confused. Let's just multiply everything by 20 and let's see what I would have had. 20 is 2, then you would have 5. 15 is 2, you would have had 14. This would have been the answer. 20 is to 15 is to 14. So what? I am getting something opposite of this. 14 is to 50. Ratio of the maximum heights that they climb. Okay. So yes, C seems to be the answer, but I am getting the opposite. Okay, so you just check the calculations one. 20 is to 15 is to 14 is the one that I am getting. Which makes sort of sense. Because the ring should have reached the maximum height also. You realize the final answers. You will realize that the final answers are independent of your radii and your mass. Okay, so these masses and radii do not really matter. Okay, AP. So yes, and that was why I had said I would have gone for A because A makes sense because the ring is reaching the maximum height, then the cylinder, and then the sphere. Okay. So here, yes, in C we are having this option, but just check once for the ratios. Whether the ratios are given in straight manner or the alternate manner. Okay. Okay, last thing is toppling, but again, toppling for a lot of problems who are not asked in mains. This is mainly an advanced kind of a topic. So for toppling, the condition is that whenever you apply such a force again, so your normal reaction shifts. So if this is some y, if this is some y, and for toppling, you realize the n shifts up to here. If you take torques about this, then the answer is you can take torques about this point. If you What is toppling first of all? What is toppling first of all? So if you apply a force on any object kept like this, okay, so here, so if I apply a force here, then it can slide like this, okay. If I apply a force here, then this, if it moves like this, so that it can overturn, this is called toppling, okay. Now the condition for toppling is, so why does it not topple when I apply a small force? If I apply a small force, what is the force which is balancing the torque of this force? So your N shifts. N shifts. The reason is that whenever you're applying this force is trying to twist this in this direction. So shifting the N, the effective position of N shifts. N comes somewhere like this, and the shifting of Nx can be calculated as Nx equals Fy. Okay, taking talks about this point. Mg and friction would not produce any torque. So if you made the FBD of this, then you would have had four forces: friction, then you would have had Mg, then you would have had N, and you would have had F. So taking talks about the bottommost point, you would have realized that Nx equals Fy. Okay, so this is the amount by which your N would have shifted. Okay, X is the shift in X, which is F into Y over M. Okay. Now you will realize that it cannot be greater than this. Okay, so let's say this is X max. X is less than equal to X max. So that gives you an expression that F into Y equals mg less than equal to X max, or F should be less than equal to X max mg over Y. So as long as the external force applied is less than this value, the object will not topple, the N will shift and N will be able to balance its toppling torque. Otherwise, if F becomes greater than this, then the object will topple. Again, if you want to understand toppling in detail, you can watch my lectures for class 11, but this was the condition for toppling. Okay, so that is it. The shifting of N due to the rotatory tendency of this is what avoids toppling. That is what you need to remember. So we'll quickly talk about one problem and then we will wrap up today's session. So this is telling you a block of mass M rests under the action of a force F against the wall as shown. Which of the following is correct? So you've been told F equals mg. If you draw the FBD, there are the different forces that are acting on this. So there is mg acting here, then there will be friction which has to balance mg. Okay, because there is no other vertical force. Then since you are applying this F, so somebody has to balance this as well. That'll be N. But where will the N act? Mystery. If you take torques about this guy is trying to rotate it clockwise. So something has to rotate it anti-clockwise. So this is where N will act. This will be FPDB. So is friction equals mg? Yes, it is. So you have to find the incorrect statement. Is capital F equals N? Yes, it is. Capital F does not produce any torque about the CM. Correct. N will not produce about a torque about the CM. That is incorrect because N will get shifted and it will produce a torque about the CM. Okay. This is the entire idea of N shifting and avoiding toppling. Okay. Now there is one more question that you can answer. Again, this was asked. This is asked in advance. So this is a PYQ advance. You can try this later. This is where I would like to wrap up today's session. I think we have discussed everything that I wanted to discuss about rotation. Now you guys get some practice and feel comfortable about rotation. This is where I would like to wrap up today's session. And before I leave you guys, let me remind you that if you haven't gotten your Plus subscriptions, what are you guys waiting for? So hurry up, get it. And this is how you do it. You go to the Plus section of the app, select your goal as IIT JEE, and click on that Get Subscription button. When redirected to the payment page, don't forget to use the code RDLIFE to get a 10% off. And these are the two plans that you can now go for, either the Plus plan or the Iconic plan. These are the fees that you'll have to pay for these two plans. Okay. And also, don't forget, when you proceed on, when you click on proceed to pay, you will also have the option of choosing from a lot of no cost EMI options. Choose an option which lessens the burden of this payment, and get the subscription very soon. Now you can also get the Iconic subscription. This subscription will take your IIT JEE preparation to the next level. You will be allotted personal coaches. You will attend regular IIT JEE workshops where you will receive expert guidelines. You will have study planners and a test analysis. Okay. Now, if you like today's video, don't forget to press that like button and share it with as many people as you can, because we want this high quality educational content to reach more and more students, because this is available to you completely for free. And if you're new to this channel, don't forget to subscribe. Don't forget to press the bell icon, and also the PDF of all these slides used in today's lectures would be available for download very soon. Bye bye, Amod Kumar. For those of you following us on JEE English channel, to be connecting with us on the Telegram app using this link. Hi AP. So this is one last time. My code is RD Live. So if you're planning to get your Unacademy subscriptions, you can use this code to get your next subscription and enjoy a 10% off. Enroll in my courses and let me be your guide and mentor through your IIT JEE journey. Okay, so that is it for today. We have wrapped up rotation. In the next class, I think we can start with the gravitation, and then we can move on to it. Okay, so I'll see you next week then. Till then, you guys take care and keep practicing and keep studying hard. Bye bye. Take care.